Hello guys, I've been asked a few times how I plan a build and decide on what components I'm going to use and kind of what the process is. So in this series of videos what I'm going to do is take you along as we try to develop a PCB that's going to provide controls for the lights in a static tractor or static truck, maybe an RC truck or tractor or even a car, it doesn't really matter. Basically, we're going to make a little PCB that we can hide in the cab, and it's going to be able to control our lights whether we're controlling it remotely or just for a static diorama. Well, the first thing we need is obviously a plan, whether it's in your head, you put it on the back of an envelope, or whatever you do, you need some sort of plan. So what I'm using here is OneNote, and what I've started with is just a list of what we want, and this can change as we go. So we want our PCB to work for both RC and static builds. We want some sort of microcontroller for the timing of the LEDs, what way we want them to flash and blink. We probably want to put some transistors on it because we might want to use some high power LEDs. We don't have to worry about damaging the microcontroller. And lastly, we need some mounting holes just so that the PCB is nice and secure in whatever vehicle we're installing it in. Now we want to roughly draw our circuit that we're going to try to create. That'll make the actual PCB design a lot simpler. So we know we have a few outputs that we want. We have our beacons, our work lights, our headlights. We know we're going to have our microcontroller. So we'll put those components in our drawing first, and then we'll draw the components that are going to connect them. It's very likely that this plan is going to change as we develop our plan, because you're probably going to realize, well, certain ways that you thought were going to work aren't actually going to work, and you're just going to have to make little adjustments to your plan. So take this example here. You can see that I've put the beacons with a transistor and a resistor, but obviously that's not going to work because we've two beacons for a start, and also we want to flash them individually so that we can have different types of flashing sequences for our beacons. You might want a simple left, right, or you might want left, left, right, left, right, right. You want to have that adjustability in your programming, and you're not really going to need the transistor because it's unlikely that you're going to need that much power to drive a beacon. You're probably only going to have one LED in your beacon. For the work lights and the headlights, I have a resistor on the transistor to limit current to the microcontroller, but I've nothing limiting current to the work lights. So the way I'm doing it is adding two resistors here, but I'm not actually going to populate the second resistor when I'm wiring this up. The idea here is that we'll put one resistor, maybe a slightly large resistance resistor, and then we can add a second one in parallel if we need to drop the resistance for higher current LEDs. We are also missing an output for the tail lights, so that's what I'm adding here. And again, we're going to have two resistors and drive it from a transistor so that we can get the maximum power out of our tail lights as well. And then we need to connect all of our LEDs to ground and provide a voltage source at the top. It's a good idea to make notes in your plan, especially if you do anything that maybe is non-standard. So you can see here I'm making a note about the resistors, why I've left two resistors under the LEDs. Just as an example, it's actually 2 months since I drew this schematic, so it can be quite a while from you draw your plan until you actually get to implement it. Next on our schematic, we're going to need a few inputs. So here we're leaving a few jumper connections just to control the flashing of the LEDs. And then we need a few inputs for our switches or from our RC receiver so that we can control the headlights and work lights and the tail lights. It's around about this point that I decide that I'm not going to use a regulator on this circuit, so that'll mean we have to limit the upper voltage of our battery. But hopefully without the losses from a regulator, we'll be able to operate to a lower voltage without any difficulty. Maybe it would run okay on two AAA batteries, or maybe even on a coin cell. Now we need to start deciding what components we're going to use. So the first step to do that is to figure out what the requirements are. So starting with the microcontroller, we're taking a look at what inputs and outputs we need. You can see here that I've realized I need another input, which is going to be for our dipped headlights on and off. We want to keep the inputs and outputs to a minimum, so you can see here that I'm creating a little logic table just to make sure that we can get all the controls that we want with the amount of inputs that we have. So just like a little logic table so we can figure out if we need these pins or not. And as it turns out, we don't need that extra dipped lights pin. We can achieve the same amount of control just using the two pins that we already had, the headlights and the work lights. We just rename them and use them in a more intelligent way. We can apply the same logic to our beacon input. So with two inputs, we can get four different flash sequences. So there's no need for the third pin, we can get rid of that. So now we have the same level of control that we always had, except we only need 6 digital inputs now, whereas before we needed 8. Now we want to choose the microcontroller that we're going to use, and since we know that we need 11 inputs and outputs, it might be a good idea to try a 14-pin microcontroller. That would usually be a positive voltage pin, a ground pin, and then 12 inputs and outputs. So kind of sounds like what we need. And I'm interested in trying the Paduke microcontrollers because I've heard quite a bit about them. They're very cheap. The programmers aren't cheap. The chips themselves are quite cheap. After doing a little looking, I think I'm going to try the PMS 152 for this application. It has more than enough PWM outputs, and then it has plenty of inputs and outputs available. And like I said, it has the positive voltage and the ground pin, and then 12 other pins are input or output. So I think it'll do exactly what we need. The only other component then that we really need to consider is the transistor. It's an NPN transistor that we've picked. And because I have a roll of MMBT 3904 transistors in SOT23 form, then that's the transistor I'm going to use, and that's usually why I use various components. It's generally just the ones that I have, and that's really the only components we have to think about. All that's left then is the resistors, and going to the transistors, I'll probably use a 1k ohm. I'll probably use 1k for the LED resistors as well. With the empty slot, you can drop that very quickly by putting another resistor in parallel. At the 1k, if your input voltage was 5 volts and your forward voltage of your LED was 1.8, for example, you'd be getting 3.2 milliamps across your LED. So that's not terrible. Wouldn't be using a huge amount of power, so your battery should last a good while. And if it's a static model, that's pretty important. You don't want your batteries running out every 5 minutes. But for LEDs, you really want to be choosing your resistance based on your LED's forward voltage and your supply voltage. You really want to work out that resistance rather than just picking a arbitrary value. And that's it really. We have our plan. We have an idea of the size of the PCB we need. Basically has to fit into the cab of, we'll say, a CQ tractor. So that's our kind of size limitation. So next thing to do is move to our PCB design software and try and get our components to fit onto a small enough area of a PCB that we can still mount into the cab of one of these tractors. So that's what we'll try and tackle in the next video. Thanks very much for watching, guys. If you liked the video, please hit the like button, and if you don't want to miss out on the next video, click the subscribe button below and get the bell on for notifications. A big thanks to all our patrons, sponsors, and you guys buying the PCBs for your own projects. That all helps to support the channel and keep the content coming. And speaking of content, there should be links on the screen now to a few more videos if you want to keep watching. And if you go to the channel homepage, you'll see that there are plenty of playlists there to check out. But that's all I have for today, so I'll see you in the next video.